Let me know once you're able to see my screen.
Yes, I can.
Okay, fine. So I'll quickly do a recap of what we covered last week with respect to artificial neural networks, so that when we get to TensorFlow, it will be easier. So we saw the definition of artificial neural network, how it was formed. It's a bit like it's got a long history. It's something which yesterday I read that one of the activation functions, the step function, was first proposed in 1957. So that's how early it was, and so it's been inspired by the neural network in our body. That's why it's called artificial neural network. It's a supervised way of learning predominantly. There was a question about artificial neural networks being used for unsupervised techniques too. So last week there was a question, and I did Google a bit. Um, Looks like it can be used for unsupervised learning too. There is something called autoencoders, I think. So uh, I need to deep dive and then know a bit more before I present it to the team. But looks like there is a possibility of using it. I'll try to cover it in the last session, which is planned for next week. Like give a high level overview of how things are being done. I haven't used it so far, so I'll have to go through that and then present it. So that's the update about the supervised versus unsupervised part of ANN. Um, it's mainly for nonlinear type of setup where you have set of inputs and then you pass it through several layers and get the output. Uh, when you pass it through, when you determine the weights and the bias for one set of weights and bias, you pass the input data and get the output. That's going to be forward propagation. Calculate the error, do the corrections, find the differentials, and so that you can do the correction for the weights and bias. That's going to be backward propagation. So these are terms which you would come across when you're doing artificial neural network. Okay, so getting into a bit more of details. So as I mentioned, you have input layer, which will give you the various features which are there for the data. You pass it through a few hidden layers. Here I've shown an example of two before you get the output. So when you pass through them, what you do is you build the we saw an intuition how it was being built. So what you do is you add weight and bias, and you also have an activation function at each node. Okay, so what happens is like for this node, for example, it takes the input parameter one, feature two, feature three, and then attaches a weight to that. There's a multiplicative factor, and there is a bias component which gets added. These things go in, and there is an activation function which transforms the sum and the sum product of these inputs plus the bias and passes it on to the next layer. Same thing happens in the next layer too. So this is how it has worked. So you have like number of nodes and number of layers is something which you determine. In case of deep learning, the number of layers is going to be much more. And we also saw the difference between normal machine learning and deep learning. Deep learning is something where the model itself learns its features. It generally tends to perform better with more data, and it needs higher computational power. That's why GPUs and TPUs come into play. It is not easily interpretable because it's got so many layers, and it's not something which you can, it's not intuitive to explain. So these are the differences between machine learning and deep learning. And we also saw why deep learning has become popular now. We have huge proliferation of data. This computation power increase also, and we have also come across applications which which need to use deep learning. And with distributed systems, microservices architecture, big data, all these things coming in, deep learning has become neural networks, and the next level of neural networks, that is deep learning, has become more popular. We also saw literally 1 minute intro of TensorFlow and Keras. We'll see a bit more details of these two today, and we'll move to the coding session. So TensorFlow, it provides a collection of workflows to develop and train models, to easily deploy the model. Okay, there is an ecosystem. We'll see the ecosystem shortly. So it also supports various languages deployment. You can convert the model to say, for example, if you want to deploy on the web, you can convert it to a JSON format and use it in your web stack to use the model. Okay, that can be done. Keras is the API layer, high-level API layer for TensorFlow. It's official. It's the default API layer for TensorFlow 2. Initially, it was not there. It was a separate one, but TensorFlow 1 had mechanism with which libraries with which like we could use Keras, but now they have made it the default API layer for TensorFlow 2. So we use the APIs for completing the model building and various activities which we mentioned. So if you move to a quick intro on TensorFlow. So it's from Google. The ecosystem, what it allows you to do is analysis and pre-processing of data, building and training model, evaluating the model, and saving the model. Okay, it allows you to, when you install TensorFlow itself, you can choose what configurations you need, whether if you have a graphical processing unit, you can install it with GPU. TPUs, of course, I think it comes under Collab, Google Collab, it's tensor processing units on the cloud. So CPU is like what you have normally on your computer. So usually the deep learning models will need GPU, TPU, or one of these for you to run them because model building is going to be heavily demanding on the system. So they also have predefined data sets which you can use for your learning, and they also have like pre-trained models which you can take up and configure it or modify it to meet your needs. So that is also something which they allow. This process is called transfer learning. Andrew Ng mentions it beautifully in his course. Like if you feel that if you browse and then if you find that there is someone who has shared a GitHub model, and if you feel that it suits your needs, there's nothing wrong in just using it and adapting it to suit your, whatever little adaptation you need to do for suiting your needs, because you don't have to spend all the time which that person has spent to, do the model building. So you can do transfer learning there too. So basically it sounds like copy paste, but not wrong if it is, publicly shared. Not a bad idea to do. Of course, in many ways, if you see the libraries are, encapsulations of copy paste activity, right? So so there's someone who has simplified the way of doing things and we are using that. So since machine learning is vast, we might not have time to do each and everything. So if someone has used and if it's been, they're saying it, you can use it for your work, then please feel free to use that. So this is the same ecosystem which was explained in a diagram. So what happens is it allows you to read and pre-process data. You have the hub, which is primarily the high-level API layers, the Keras and pre-trained estimators, which you can use, and distribution, which will be either CPU, GPU, or TPU distribution. And it allows you to save the model, load the model again, run it against the data, and after that you can deploy it to various applications either on the cloud or you want to embed it, mobile, browser, other language bindings are also supported by TensorFlow. There is a YouTube video which I saw like where the person is he's done a mask recognition model, and what he does is he has built it and then he's deploying it in a web application. Like you use the webcam, you see the image, and the model determines whether the person is wearing a mask or not. So I can send you the link. It shows like at a high level, and he has also shared the code in GitHub. At a high level, how this can be done, how he has embedded the model in the web application which he has built. So he's converting it to JSON and then using it in his web stack. So that is how he has done. So I can share that link in the Teams for you to have a look at it. That will give you an idea, since deployment is not something which you're covering in this session. So it will give you an idea how it can be done. That's the end result, right? So it will give you an idea what can be done with this. So that's the theoretical part of this. So any questions before I move to the coding walkthrough? Okay. My usual statement, I'll take that as a no, and then I'll proceed to the code walkthrough. Okay, for the code walkthrough, what I'm going to do is I've taken an example where like just random data, 1,000 data points, As always, like maybe housing price, the square feet of area and distance from city center is what I've taken. Just random values. Please don't check whether these are valid values. So I take these values, build build the model and show you. Of course, this is without, since it's random values, it's only for explaining how the model is going to be built. I haven't done the exploratory data analysis part. And this is the other piece of code which Jose's course in Udemy has given this to me. So they've said it's copyrighted. So I'll walk you through this, what data has been taken, and the exploratory data analysis part. He's explained beautifully what can be done. Of course, this is a regression example. This is not it's just an example. So you might have to do, when you are doing the data analysis, you might have to do sometimes more steps, sometimes less steps. Everything is possible, but it will give you an idea what are the different steps that are involved. Of course, he's just stopped it with model building. The model is not very accurate, but I'll show you how these things are being done. And this is, of course, I'll show you an example where I did an overfitting, which I was talking about a couple of sessions back. And there is one more link for the overview of optimizer functions, which we can look at. So I'll share this link in Teams too. Okay, with that, I'll get started with building neural networks with TensorFlow Keras. Okay, so what I'm doing is I'm going to use the libraries which are there, pandas, for creating the data frame. And I'll also use matplotlib and seaborn. Seaborn is something which we haven't covered in our session, but some examples are there with which like you can understand what it is being used. It's mainly for doing the statistical representation. Like if you want to do a bar chart, you want to do a histogram, you want to do a scatter plot, you want to do a box plot, you can use for all those things. These are plots which will give you a good view easily. Of course, the other thing is matplotlib, with which you can do the normal other type of graphs too. So what I will do is I'll use both these things. You will see how it is being used when I'm going through the session. Okay, so fine. Sorry, in this example, I wouldn't be leveraging a lot of Seaborn. When I go to this example, you'll see the value of Seaborn, but here it's just using the graph for determining the loss, how it is going to happen. Okay, so that is what I have done. Okay, so I'll import pandas, and I've created just a random data thing. I downloaded and then I've just modified some values, created random things. So I'm going to read that, convert it to a data frame, and then see what the values are. Just head will give me the top 5 values, what columns are there. So I get that. Then after importing, what I'm doing is, since it's random data, I'm not doing exploratory data analysis. Just for simple example, so I'm straight away going to test train split. What needs to be done? We saw this in one of the earlier sessions. So I'm taking the values from, if you, after reading this data frame, I'm taking these two features as the X value and price to be the Y value. Obviously, these are the inputs and this is the output. So after I do that using the test train split class, which I can, the function call, which I can you get from scikit-learn, I'm saying that the test size is 30% and the train size is 70%. So it will split it into 700, 300. So that is what I have done here. Okay, and this is the next thing. I said we did not do exploratory data analysis, but we are doing a bit of pre-processing, just scaling the input so that the model can run fast. This is the maxmin scalar, which will just take the range within the within that column and do it, convert it to scale it to 0 to 1. That is what it will do. So if you look at that, so we'll take help, and if you want to, and this is for any function, if you want to see help for any of these function calls or classes, you can use help and then do this. So you create an instance of this and then fit it in the training thing and transform the train data and the test data with the scalar. Okay, and now we are going to the TensorFlow part. So you have you import TensorFlow, Keras. From Keras you have the models which you will use. I'm using a sequential model. Sequential is like you create the layers of neural network as a sequence. You define like what is going to be the number of units, what activation function, number of nodes, and what activation function you're going to use. This is the simplest way of building using TensorFlow Keras. So I'm following that. So import that class, and also like get the dense and activation portion of it. There are two ways in which you can build the layers. So one, you can just create it and give all the layers together, or what you can do is you can start adding layers one by one. I would prescribe the second method because in case of overfitting, if you'll have to do some one way of dealing with overfitting is randomly you know switching off some of the nodes. That can be done at at each layer level. So if you do it this way, you can add that piece of code in between. So that is something which you can do. So here, this is just an example, two ways of doing it. What I will do is in the actual model, what I'll do is we'll add uh, dense, this is 4, and activation function there at that, the transformation function which I spoke about, like what we have seen, like gradient descent or sigmoid or step function. I'm taking relu here. Okay, you can take it as a general advisory. This is something which Jose mentions in his course. I've copied it here. So you can take it as general advisory. You can try this out for multi-class classification problem model. Start with, you can have optimizer as RMS prop, and then sorry, I said gradient descent as one of the activation functions. Sorry, it is the optimizer function, not the activation. Activation is step function, sigmoid, relu, all those things you'll see. It stands for rectangular linear units. I think it's basically anything less than 0 will be 0 and above 0 will be the value itself. So it's something like I'll search and I'll show you the activation function. So if you look at this, this is the activation function for relu. So sorry, it's rectified linear activation. So what happens is anything below 0, the output is 0. Above 0, it is the input itself. That is the simplest. Like it's like something like a sigmoid function or step function. So that's the activation you determine. If you remember when I covered this portion, I mentioned that at each node, we need to say what is going to be the activation function. At each layer, we are going to mention what is going to be the activation function for the nodes in that layer. So that is what we are covering here. So here, the 4 denotes the number of nodes. OK, and this is going to be the activation function that's going to be used. I've added 3 layers here, just as an example. And the last layer I have added is for the output. OK, so this is what I have added. And what I'm doing is when I'm compiling the model, I'm saying that optimizer is RMS prop. This is one of the methods with which you can do. And loss, the metric which you use is mean squared error is what we are going to use. So this is a regression model, and there's a general advisory too for classification problem. What you can use for regression model, what you can use. Classification itself can be multi-class classification or it can be binary classification. So the difference between these two, multi-class, you can have like in a particular image, if you're identifying the cat, the dog, the car, that's going to be a multi-class classification. Vis-a-vis binary classification is like if you're giving an image and just checking whether the image has a cat or not, that is binary classification. Regression you already know. So I will compile this model. And after that, what I'm going to do is the model is built now. So I'm going to train it by giving the X values and the Y values. If you remember, we had already split it here and scaled it. We had taken 70% of the data to be the trained data. You'll have the X and Y values for that. And we had scaled it using the scalar transform function. And with that, like what I'm going to do is I'm going to pass it to the model, the compile model, um, fit it into that so that the model can be built. There is another term which I have used, epochs. Epoch is single pass of the input values through the model is one epoch. So what happens is the model will start with random values for the weights and the bias I was talking about here, the weights and the bias, right? It will start with random values for those, and then it will pass it through, like it will take the inputs, pass it through this, and that is one epoch. So I've given 250 here so that the model can, this is a forward propagation, backward propagation logic. So next time what it does is it corrects the weights and bias so that at different layers so that it can get better output. And what it does is for that it will use the mean squared error as the metric to get to the correct value. So I've given epochs can be high values depending on how long it takes for you to convert. So what I have done is I've taken as an example, I've taken it as 250 here. So what happens is you run the epoch. What it has done is you see the loss which is here, and if you notice the loss is going down. Okay, and finally it has reached this value at the end of 250 epochs, 250 runs. And what you can do is you can get the history, the loss from the sorry, the loss from the history attribute. So you run the model.history.history, you will get the loss. What I will do is I will store this. Okay, and then use Seaborn to plot it to see uh, where we are getting in terms of the loss. If you see here, if you notice what is happening is initially the training loss is very high. Obviously it's taken random values for the weights and bias, and as you proceed you can see it coming down. But after around 100 epochs or 120 epochs or so, you don't see much improvement in terms of loss. So you can determine that okay, the weights and the bias which you have gotten with this value is getting you, as far as the training data is concerned, the desired result. Okay, so this is the loss graph which you're going to see. Okay, and then now what we are going to do is we are going to use the model built to predict what values you're getting. Like we have the test data, right? So we are going to predict what values are going to be there. So we pass in the X test values and then do the predictions. Okay, and you create a data frame which has both these values. Okay, for this you need to reshape and then concatenate. So so you get the columns. I've basically created. If you okay, 1 minute, I'll show you this too. Um, so if you look at this, so you get test y, which is the actual value and the predicted value. So you see how the model has done with respect to each of the inputs which we have passed from the test data. Okay, you get this, and then we'll look at the analysis, like how the error is. So if you look at, we get the mean absolute error and mean squared error from scikit-learn, and you give the predicted value, sorry, the actual value and the predicted value, pass it as parameters. It will give you what the mean absolute error and mean squared error is. Okay, so how do we give it a new value? Say just new gem which we are passing on, and then just create. And please remember to transform the data because we have scaled the input, right? So before you pass it on, you should transform the data and then use that for predicting. You will get the value what you need for that set of inputs. This is the value which is going to be the output. So this is for any new input. Of course, we don't know what the actual value is. This is the predicted value as per the model. I'll pause here. So we have seen a very simple model building of neural networks with TensorFlow and Keras. Any questions? Okay, I'll take that as a no. I also mentioned when I spoke about TensorFlow ecosystem, we can look at saving the model and reusing it. So that is something. See, what happens is at the end of the day, if you do what a machine learning person or a data scientist does is builds model, gives it to the business team for them to deploy it in production, right? So there should be some way of saving the model and passing it on. So TensorFlow has a very good way of both saving the model and then taking it to deployment. So what you can do is you can save the model with this command model.save and give it a name. It's hy is the format in which it will be saved. So if you want to use an already saved model, you can use the load model command and load the model. And you can use that for predicting. Sorry, I didn't get it here. Okay. Okay. So you can use it for predicting for any new values. So what we did was like we saved the model, loaded the model in another variable, and we use that for in another object, and we use that for predicting value. So this is simple introduction of user building neural networks with TensorFlow, saving the model also. Okay, so now I'll go to a more complex example. This is more like a real world thing which done with the Kaggle data. It's not going to be, what I showed was more like a happy path testing. Like you have like the simplest methods, everything data was pre-processed and given to us. We had to only scale and then do that. But here we look at like raw data which is taken from Kaggle. This is for the housing price prediction. I think this is in a county. If I remember it right, it is Kings County in Seattle. I'll try to get you the. Yeah, Seattle, King County. This is the one. Okay. So remember the shape. Okay. This is, I think, downtown of Seattle. I haven't been to Seattle. My guess is since Space Needle is here, this should be the downtown of Seattle. Please remember the shape. We'll see that in the model building. When you do a plot, you will be able to see correlate. Okay. So it has got feature columns. So which are there, which is giving you information about the various parameters which they feel will be affecting the home price. Like it will be the date of home sale, price, bedrooms, square feet, whether it's a waterfront property or not, square foot, basement square foot, above year built, zip code, latitude, longitude, what is the living area square feet. All these parameters, you have the data for this. So what has been done is import the data, import all the libraries, import the data, and we'll do an exploratory data analysis. So first thing is check whether there are missing values, is null, whether there are so if you notice here, there are all these parameters, none of them have missing values, so which is good. Otherwise we might have had to deal with like what do we do with those missing values. Do we take only the values which are present, or fill in with those values that should have been there in this data set? It is not there. Okay, just he has transposed it for him to just have a better view. So if you describe what it does is, if you use the describe function, what it does is it gives you the values of like what is the count, what is the mean for that particular column, standard deviation, minimum, what is the 25% value, the percentile value, what is the maximum value. So all these are given. This is something which you will get with describe. If you don't do a transpose, all that would have happened is the count, mean, all those things would have been here, and the column names would have been here. He has just transported for better readability. Okay, and then what he has done is he has done the plot of the price. This is the um, if you see the histogram plot of the price, how it has happened. So if you see here the figure size, this is where he's using the Seaborn library. If you remember, he has imported Seaborn as SNS. Using that, he's created this plot because the input is provided. And you see there are few properties which are having very high value, but majority of them are less than $250,000. So he has also done a count plot of bedrooms. If you see, there are I think 7 bedroom is the last one. Majority of them are either 3 or 4, few of them 2 and 5 here. So he has done this plot. So it gives you an idea about the data. So you're doing exploratory data analysis for you to know like what the data speaks, right? So that is something which is done. Okay, and then he has done the plot for price with respect to square feet of living area. Okay, what we saw that as one of the parameters here. If you have this, so the square feet of living area. So depending on that, what the prices is what has been seen here. This is how the variation is. This is a scatter plot which has been done with Seaborn. And you can also do a box plot, which explains like in terms of number of bedrooms, what is going to be the price range. And for people who are new to box plot, like what it does is it gives you the complete range. you can see the outliers, and I think it's 25th percentile and 75th percentile are mentioned here in the box plot. And I think the median value is denoted by the line here. That's how you interpret a box plot. So you see how the variation is going to be for the price with respect to the number of bedrooms. So this is also, it also gives you an idea of how it is distributed. Okay, and you look at the geographical properties. So what happens is like whether the location, of course, the location will have a role to play, right? So the location affects. So what they have done is we have the latitude and uh, longitude information. So here it is plotted against the longitude, the price variation with respect to longitude. It will be negative because it's west of Greenwich, and you can do the same thing with respect to latitude. Latitude will be positive because it's a northern hemisphere. You see this. So what will happen if you combine both these things? So that is what you will see here. So if you see here latitude and longitude, if you combine, so what is happening is latitude is the horizontal line and longitude is the vertical line, right? So if you see here, what he has done is he has done a scatter plot, given longitude as X value, latitude as Y value. What he has also done is hue as price. So what will happen is here, like depending on the price, he's created hotspots here. So I told you, remember this, right? So if you see here, if I zoom out, are you able to see this pattern here? So with this pattern, you're able to locate like what is going to be the price range. So of course, the higher price ones are going to be somewhere here, few of them here, and this is waterfront. Maybe that's the reason it's highly priced. So you see this, and the range is also provided here. So this is like you can create a scatter plot with hotspots marked actually. So that is also done here. Okay, what he has done is see, and next what he does is we saw here that in this graph, you see you have some outliers. So if you're going to build the model based on these, it's going to change. It might not do justice to the values which are majority of the values which are here. So what he's trying to do here is split it, see what are the values. Okay, take the price value, see, set it in descending order. Okay, maybe get top 20 values, see what the values are, and then find the top 1% of it and maybe remove it so that you deal with a few of the things which are there, which are more relevant to the model building. This might not be there could be some data which would be, which might not help in our model building because these are outliers. So what is being done is it just takes the top 99 percentage which is there. So you will remove like 215, which is 1%. So uh, the total number of values will be around 2000 odd. So remove that and look at building the model, see whether that can give you a better result. Okay. So what he has done is he has removed that and removed the top 1%, built the same graph, what we had seen before here, with a slight difference. What he has done is he has used a palette for, you can also choose a palette which you want to represent. So otherwise it's similar to this one. Here he hadn't chosen the palette. So he has chosen a palette which is going to be red, yellow, green type of combination. So the darker ones will, the green ones are high priced ones and the red ones are low priced ones. If you hadn't used, the darker ones would have been the high priced ones here. Okay, so he's just done that, and you can see a pattern of how things are. Like low priced ones are here, the high priced ones are marked here. Okay, look at other features too. Look at we should continue exploring the features to find out like what will be relevant, what will not be relevant. So the box plot for waterfront and whether it is influencing the price. If you see that, there is definitely a difference. The waterfront properties have higher price. So we know that this is an important feature. Look at the other columns and there's some transformation which we'll have to do. For example, the date is here. Okay. But date is not going to really, you cannot, if you want to pass it on to the model, maybe what you'll have to do will be you'll have to pass the year, and maybe if there is seasonal variation within a year. Okay, then you say if there are school starting season, if people are going to look at moving or buying a property just before the school start, you might have a higher number of sales. So that will be denoted by the month. And in this example, I don't think date is giving you a significant the data has a significant influence with respect to influencing the price. But if you look at the year and the month, it might have an influence. So we might have to transform this date column to have the year and month that has to be done. And there could be few other parameters which might not be of any use. We are already using latitude, longitude. So say for example, zip code might not be relevant. So we might have to remove those. So get some information about those individual columns which are there, decide whether you need to transform the data. Those things can be done. Say, for example, ID is not of any use. It's just a way to denote. It's not going to help you in the model building. It's not a valid input parameter. So you can drop ID. So that is what he's doing here. Okay, and then feature engineering from date, what I told you. So what happens is he's basically converting this to from converted to data frame, and then apply the month. You have a function with which like you can get the month, you can get the year. So this is basically this syntax is you take the column value and you apply, when you say lambda, you apply this function on the column value and get the details. So for example, like if you take date, what it does is it takes this 10/13/2014 and then it applies this formula, this function to get you the month of this one, of this particular entry, which will be October. So what it does is like if you take for this value, it will have returned October. It does it for all the values and that is stored as a column in the data frame. And then you create another column which is going to be for year, follow the same method. So if you see those things, you'll get the year. This is basically like 2 years data which has been taken. So you see only 2014-15, not much difference in terms of price, but where it might help will be the number of years, like from how old the property is. That might be of use. So month, if you see, this is the variation, and as I mentioned, like if you look at like how the mean price is with respect to the month, you can see that it is there is a seasonal variation which you can see. It could be due to various reasons. School start could be one of the reasons which I had mentioned. So all these things will see. What I'm trying to say is for this problem, we know the domain, like saying that the price could vary due to this. It could be, there could be, these are the factors which might influence. And that is the reason we are able to identify which parameter will be relevant for model building. So if you're looking at some other problem, then you should know what the problem is. And if you remember the process which we had worked out for machine learning model building, so you have a hypothesis generation. When you're doing hypothesis, you are trying to look at ideas, concepts which will help you understand what might influence the problem solution. So in this case, we sort of know what is going to happen. So based on that, we are doing the exploratory data analysis, and we are also validating it when we are doing with exploratory data analysis. For example, if month it had been a flat line without any change, then we wouldn't have actually bothered much, right? But here you see a variation which is there. Okay, here if you see, there is definitely, here we saw that in the box plot, maybe the range was too low because this is if I'm not wrong, this is 1 million. So we couldn't see the difference. Same thing here. But if you see the interval, if you do and a more detailed plot, there is a small variation, like it's 539 to 542. And then now with this, see, we have converted the date to columns which we need for doing the model building. So we'll drop this column, and then now we have the list of columns which are there. Okay, if you look at zip code, it's not of much value to us. We can look at dropping it. And then with because latitude longitude is already going to be a substitute for zip codes. So, and other reason is like these are numbers, and model shouldn't be uh, taking these as values and interpreting it differently. For example, like it shouldn't interpret that zip code 98103 is more than 98038. So that is something which we should avoid, and that's also a reason why we are dropping this. And then if you look at the year renovated, we have these things which are coming in. The counts are seen, square foot basement which is taken. So with all these things explored, not pre-processed completely, some transformation done, you have the columns which we need for doing the model building. So this is exploratory data analysis. Any questions till now? The group is very silent today. Am I on the call?
Yeah, you are very much on the collar, Shah. I know that feeling because I've done that same. I can
Shouldn't be
relate to
that it's a monologue, right? Okay.
it. Yeah, guys, you got to encourage the speaker. If you're silent, he will not be motivated. So ask him some questions.
The other way is I would want to believe it to be true. I'll use the statement which Kader has used when he talks to us. So either my explanation has been spot on, that you're 100% clear about what has happened. Otherwise, you need to ask questions. So please choose one of these.
Yeah, I have a question.
Very, very feeble. Can you please speak louder?
Yeah, I have a question. Can you? Maybe I
Still not able to hear you.
can I can I type?
Hello?
Can you hear me? Can you hear me?
Can you type the question? Your voice is very
Yeah.
feeble.
I've typed.
It's tensor processing unit. It's part of this one, Google Colab. Cloud. Like you have the GPU in your, you add it to your PC, right? Like that, you have TPUs. Any other question? Okay, so I understand why there might not be questions, because there are many topics which are covered, so it might take some time to digest. So what I will do is for this portion, as I mentioned, I will not be able to share the code as it is now, because this is something which Jose claims it's copyrighted. Okay, there's one more question. It's a cloud hardware. Okay, so what I will do is for this notebook, what I'll try to do is to help you out. I will take a dump of all these commands, create a separate text file itself, so that, and I'll also enter details like what you can use this for, those things, and I'll share that notebook. This as it is, I cannot share, but the learnings from this I can definitely share, right? So what I will do is I will create a notebook from this where it has got these commands and what it is for. We can do that, and I'll share that notebook so that you can go through this. You can use that for your model building too. See, I'm whenever I have when I'll have to build a new model, the first thing I do is I keep all my existing models open so that I can go to one part of the code and copy and paste. So don't feel bad about that. You don't have to know these commands by heart, but you should know what you need to use. Okay, no one is expecting you to know all the commands, each syntax 100% correct. No, you should know how to get it, and if there is an error, how to solve it is what you'll have to know. So I'll copy these commands and give you a separate notebook. As I mentioned sometime last week, I think there were requests for other pieces of code to be shared too. I'll do the same thing, and I'll create a set of notebooks, give it to you. You can use that for going through, understand the stuff. And if you have any questions, you can ask in the next session or in the study session. Will that be
Can I
okay?
can I see the graph for the yeah,
Which
okay,
one?
those are scatter plots, yeah.
Yeah.
Okay. The next one, I just wanted to see the code for it. Yeah. Yeah. Okay. So it's palette that give it origin.
Yes, and you can select the palette which you want. You can just search for it, and then you will get the palette whatever color you want, and it gives with the legend, right? So say if it is it's ranged it from red to green with respect to low price to high price. I personally prefer this because single color
Okay.
darker will be better. It's just a way of representation. See, if you remember in this one, And when we had the matplotlib session, you have a way of like markers, giving it a border color, fill color, thickness of the border, all those things, right? You can always keep defining a lot of things, but to keep it simple, I can, this gives me the idea, right? So for example, this portion is more like, if you go to the map here, it's the downtown portion, right? So
Mhm.
that portion is more expensive, more logical explanation. Or waterfront properties, if you see here, this is going to be the waterfront. Where is this? I'm not able to compare it. This here, this here, right? So we see that the waterfront properties, this is the King County. So there are waterfront properties here. That's the reason the price is higher. So I personally prefer this, but you can also, whatever you're convenient with, you can do that.
Okay, so let me ask you a question.
Yeah.
For the scatter plot, right? Sometimes the data doesn't fit. There's a word for it. I don't remember, but you know what I mean. Like some of the there's a name for it. Like the plot. Some of the plot would be very far away from each other. There's like some problem when you're working on.
See,
You
that is
have
the
to
reason.
clean.
Yeah, in
Good.
this case, yeah. So what has happened is, see, this is also a scatter plot, right? So this is also a
Mhm.
scatter plot. So if you see there are values, it is adjusting the scale accordingly.
Yeah,
You can
but
also
I see
define the scale and
this
keep it
part on
within that.
top. That point on top, it's all the way by itself.
Yes.
So there's something they usually do, like trying to bring all these points closer to each other. So
See,
I forgot what. Well,
my question is whether you should bring it closer. When your actual data is keeping it farther, why do you have to bring it closer? You can, what you can do is you can define the range when you, my guess is when you're saying you're trying to bring it closer, what you're saying is increase the range so that like the graph looks compressed. So you will see it closer. Is that what you're saying?
something similar to that. Yeah, but I forgot the actual term. But
I'm not able
I
to
look it
relate
up.
to your question,
Yeah.
but what I'm trying to say is, see here, if you see, if the data is farther from the majority of the data points, leave it there, decide on whether you need to count it as outlier and leave these values or not. See, what is going to happen is this would influence the model weights and bias, okay, which might hurt the, the prediction for these values. And when majority of your data is going to be here, it's better if you focus on this, right?
Hmm.
So that is important. That's a call which you need to make. If you want to see it visually, bringing it closer, all that you'll have to do is increase this range and this range. If you this okay, this if you increase it to, say this is price is 800,000, you make it say 2 million or something like, or sorry, this is not 800,000, it's 8 million. If you want to make it like 10 or 15 million, then all these will move closer. But you're losing the crux of it, right? Because majority of the data points are here.
Yeah, I don't remember the term exactly. Maybe
Okay.
I'm not saying it well, but I'll look it up. I'll get
Yeah,
back at you.
you can message in Teams and then we can see. Okay, fine. So any other question before I go to the model building? Okay, I'll take that as a no, and then I'll move to model building. So since we are here and we have
It's I was talking about outliers, like clean the outliers.
yeah, clear. That's what I said. Cleaning the
Yeah,
outliers is you're not bringing
yeah.
them together. What you're doing is you're you will remove the outliers. So what you will do is for this data, I'm just giving an example. What you can do is, since majority of the data points are going to be here, you just take only these values
Hmm.
and remove these values and tell them that say these are outliers because, or you need more data points for these for you to use it in the model.
But I don't think Jose did that in this graph in that case.
He has taken only 99% of the values here.
Mm.
So if you look at this, what he has done is here he has taken only 99% of the values. This graph is taking only he has dropped around 216 data points.
He's dropping some value. Yeah.
So that's a call which you can take. But in spite of this, since I know the model result, it is not a very accurate model. He's just explained it and left it at that, and he's given us an exercise to do what needs to be done with respect to such things. So since I'm only doing the explanation, I'll also stop it at the same point. But what you're saying is right. You need to look at removing the outliers so that if you include these, it will influence the model parameters, which might
Mm.
hurt majority of the values here. So you should look at like taking the values only till this. He has taken more than what I'm drawing here, because he's taken 215 values out, which means like it's like these are definitely more than less than 215. So maybe he has taken only these many.
Because I know when you're building a model, sometimes there's some trial you gotta go through, like see if you remove certain data, if it'll improve the accuracy of the model, or if there's stuff that you keep that would give you a better accuracy for your model, so on and
Yes. Let us not leave your question as it is. 1 minute. I will. Oh, I didn't run this. Okay. No, I'll not be able to do this. I need to run one by one. It might take a long time. So what I was trying to do was create the scatter plot after
yeah,
the values are
you don't have
removed.
to do it. It's okay. You don't
Okay,
have to do it.
so
Yes, that's why we have study group, guys. So we can move on. Yeah.
okay, fine. So we saw the feature engineering with respect to date. It can also mean like more complex feature engineering and dropping some of the values which might not be of use for model building. We have done that, and now we are going to the model building part. So what is happening is doing the test train split. So here same thing, 70% train data, then 30% test data. Scale it, use the max-min scaler. Do that. So this is how it is taken. Okay. Hey, 1 minute. I was wrong when I mentioned 2,500 as the total. It's 215 is 1%, which is 25,000 is the total. Okay. Sorry about that decimal mistake. So what you do is you have the split here. So you have like close to, this is after removing the 1% value. So that is what you will have here. You have 20, close to 22,000 data points, right? And you create a model like what we had mentioned. There is an optimizer function. He has used Adam. It's one of the optimizer function. I'll share this link for you to go through the optimizer function. This is something which you can, where you can get the overview of the different optimizer functions which can be used. Gradient descent is one of them. Okay, we saw. Oh, sorry, I don't have access. I exhausted my access, but here he gives a list of optimizer functions and how it can be used. And which is the best too. There are many of them. It might be, some might be overwhelming. So for now, assume that Adam is he has also concluded that Adam is the best optimizer function. So use that as what he has mentioned. So you can use that. And here we saw the activation at each node that has been used. So what he has done here is 1, 2, 3, 4, 4 hidden layers and one output layer is what he has created. And since it's a regression problem, he has stuck to mean squared error as the loss which is required. So, and then you do the model tray. The model has been compiled, created and compiled. Now fit it with the train data. So this is where the benefit of TensorFlow comes into play, right? So what it also allows you to do is give you the feed in the validation data, that is the test data. Okay, so while you're training the model with training data, you can also give it the test data and y data, test data, that is x data, x test and y test. Okay, determine the epochs and what is going to be the batch size which you want to run with. So do that, and you have the losses which you compute. Okay, and when you do the plot, what it does is it gives you the plot for both the training loss and the validation loss. This validation loss is computed based on this input which you have provided when you're building the model. So please understand what happens is the model is built with the train data And what you're doing is you're passing the value, you're passing the details of the validation data to, so that it can, if when you're using it, when you're doing the loss computation, it can compute the loss for validation also. So if you see, if you look at the number of epochs, so beyond a particular value, you don't see considerable improvement in the loss function. So you can zero in on that and say that this is the set of weights and bias I'm going to go with at this point of time. TensorFlow allows you to do that too. If you don't see an improvement in the loss value, instead of running all the epochs, say for example here, I think 400 is the epoch, right? So instead of running it 400 round times and then stopping it, TensorFlow allows you to define. It is not in this notebook, but TensorFlow allows you to define at what point you need to stop. When you don't see the loss improving at all, you can stop the model, stop the number of epochs and say that this is the best value which you've got so far. So this is the reason. So to explain this graph, you have the loss value for training set and the validation, that is the test set. And you see that they are tracing pretty close, which means like you don't have any difference between the training set improvement and the test set improvement. So you can conclude that they are trending equal, they're trending similar. So depending on like what the loss value is, you can conclude that beyond this, there's no much improvement. We can freeze the weights and bias for that. That is what you can do. I will also show you another notebook. This is my work. It takes some time to load. Okay. If you remember, I said that I had overfitted a value, right? So, okay, this is the graph which I wanted to show. So this is the train set loss and this is the test set loss. Okay. In one of the sessions, I told that I had fixed the number of, this is using random forest. So number of estimators is number of trees in random forest. So I fixed that at 1750. And the person who assessed this model for me, she said this, see, if you notice here at 1750, I know that you've come to this level and then you saw an improvement in the training data and you've concluded. But if you notice beyond this value somewhere here, you don't see an improvement in the test set error metric. So if you're going to proceed beyond this, what is going to happen is you're only taking care of the training set improvement, which means you're overfitting the data. This is something which should be avoided. I should have actually recommended somewhere here, because after this, I don't see any improvement in the test set values. See, this is a balance. We saw the overfitting, underfitting, bias variance in the first few sessions, right? So that's a balance you need to strike. But here I could have just concluded based on this itself, because it's not much of, if I do this, I might be risking overfitting the data to the training set, so that when there is a new set of data which is going to come, I might not get the correct prediction. So this is the actual usage of this graph. Okay, so here it is not happening, but if it happens, you know what needs to be done. And TensorFlow allows you to do that too. When you don't see much improvement in the test set error metric, you can stop the epochs and say that, okay, this will be the value with which I'll conclude the model. So that can be done. Okay, now we'll look at more detail. We saw the error in the test data. We'll look at more detailed test data evaluation. So what you do is we'll get the mean absolute error or mean squared error. We'll import those things. And then we know what the X test value is, scale values here between 0 and 1. Use the model which you have built, predict it. You have the mean absolute error for the actual value and the predicted value. You see this, and mean absolute error is just it's not the complete metric, because it doesn't take care of directions are also involved. So it's not going to give you the actual indication of how good the model is. Look at squared error, look at the variance, those things. And what is the mean price? See, this is the reason I'm saying it's going to be the mean price is this much, but if you're getting an error of this much, it's not a very great model. It's definitely something that can be done to improve this. So if you look at this, what has happened is if you look at the test values and the predictions, like, and also draw a line for what the values are. So this is where the difference is. while y test is here, right? This is the actual value. This is the predicted value. So for this, if you look at it, I'm not able to make this is I think 8 million, right? So it's predicting much lesser. So these are other metrics which you can use for analyzing how good your model is. And of course, the last part is using this for predicting how the value should be for a new entry. If you get new set of inputs, like what should be the predicted value. So if you look at this, what is happening is we have taken a value from the data point itself. So the price is actually 221,000, but what it is predicting is 283,000. It's a good amount of variation. So I'll pause at this point, but the model definitely needs some improvement. Like what you had mentioned, Samuel, maybe we'll have to look at removing the outliers, more outliers removed, making it predicted properly. That is also one of the ways which we can look at. So, but this is the end-to-end cycle for model building. Any questions?
No, no, I was just thinking like sometime when using this data, I don't know for um w- TensorFlow and sometime when you use like values like related to like really related to the problem you're trying to solve, so you're gonna get very good accuracy, which gonna be considered cheating. So the model is not really you're not really solving the problem. You're just getting like, because like when they give you the data, some of the data is just relevant. Like if you use them, it's just gonna give you like 100% accuracy. So
Okay.
I'm not sure I explained it right.
So with that, I'm done with the portion plan for today. So next week, what I'm going to do is I'll have to look at NLP. So for NLP, there is one more RNN is something which I'll have to introduce briefly and then go to NLP. So I'll do that. So the first half of the session will be introduction to natural language processing, what it is. Then look at a quick, I'll see how I can quickly introduce RNN and then take you to, how we can use TensorFlow for some text processing is what I'm going to look at. So that will be the plan for next week. So with that, we'll be completing the master class. So Kadar, I'll leave the floor open for survey. I'll stop sharing.
Yeah, thanks, guys. First request that I have for you all is don't leave, right? I'll tell you what do I mean by don't leave for this survey. People started leaving, right? Harsha, that's why we got to do this in between. Um, I started seeing like 18 people now. The survey, it's only 14 people. That's why I was kind of interested doing it, because the survey is so important, team, that we provide this program for free, right? You're not charged any money. If you actually are going for any other programs, you probably will be spending hundreds and thousands of dollars. So from the Testoper community, we basically provide this program for free to help you guys to learn and become successful. So that's the message, and the survey is the one which will really help us not only to really understand you guys and do this program better. It's not for that, right? Because we are not an event company, we are a non-profit. We all come together, we learn together, we develop together. But the survey that we do is to really understand the demographics and understand your willing and understand how you wanted to contribute towards the success of the community, and many different things, right? So that's why we basically conduct this survey. So what I suggest is, Harsha, next week we will do this survey. Maybe we got to do this in a break where everyone is there to do it. But for now, what I suggest to everyone is that I'm trying to share my screen. If you, I'm sure that most of you are already having the access to the Testoper. Let me check. So Not many. Okay, Samuel, you don't have access to, you have not logged in into Testoper. Aneta, you have not logged in into Testoper. Amaryllis and also JY. You have not logged in into Testoper. What I suggest for those who don't have access to the Testoper, first get the access to the Testoper teams, and you know the process already. But however, what I suggest is you guys to copy this link. I think I did put that link starting of this. Let me check. If not, let me do this quickly here. Okay, copy the link, and then put it here. All right. So can you please copy this link and keep it in your local, whatever the document from the chat, so you can fill this survey. So by clicking this link, you will be taken to the survey that you can fill it in. Okay. And I would really appreciate your help in filling this survey. And those who already have access to the Microsoft Teams, for you guys, it's pretty straightforward. All you got to do is go to Teams, go to Masterclass, right? So we have all these channels, go to Masterclass, and then in the Masterclass, there is a next to the YouTube, there is a link here. You can click this link and then start filling up the survey. All right. So what we will do now is I will let you, please just take 3 to 5 minutes to fill up the survey. Please finish the survey. And what we will do is we will do this again in our next session in between before closing, right? So everyone is there, and I wanted to really look at this survey and share it with you guys who attended, who were your neighbors, even though we are online, who were your neighbors, from where they are coming, which country, what job they are doing. I just want to create this kind of an understanding between all of us who has been attending this this program. So the closing words, understand the survey is not to improve how we perform, but to rather really get to know you more, and to help us to really see how you can contribute towards our community. And plus, all these surveys really helps us to project ourselves for our growth, right? If you actually go to the testoper.com, and if you look at our website, and there is something called as a statistics, right? If you go to the statistics, you would actually see that we track all the things that we are trying to do, how many people have attended, what kind of programs that we do, what kind of geography that they come from, and different types. You can actually see all of them in our website, right? So this is where whatever that you provide helps us to kind of display ourselves better to the people who wants to really come and learn from us, right? It's not for any other reason. So keep that in your mind, and help us with filling the survey, and we will review this outcome of the survey in our next call. Harsha, I did not want to stop your flow today, but next final session, we will have to stop your flow in between and review this together. Okay.
Okay, we can also send a mail to everyone. We have their email IDs, right? So we can send the survey to them, and then we can review it in the next session.
Yeah, we have done that. Doesn't work, but
no, we'll try that out. We are doing all these things.
Okay.
We are doing it
So
in week
I would
5.
appreciate Harsha, if you could take that as an action, and you have, if you can send it out, I would appreciate it. Yeah,
I can do
if it
that.
comes from the speaker, probably I might get some response, because I've done that in the past. Email doesn't work, right? So
yeah, I have the link here, so I can take it and send it across.
Perfect. Thank you very much, guys. I'll also leave a little bit more time to you all, and then we'll go from there. Please, before you shut down your computer, finish the survey and shut down your computer. We'll review this together in our next call.
And as always, please let me know if you want me to change my approach, or if you want to learn something else. Please let me know. These, as Kader mentioned, these feedback points will help us plan the sessions properly, and do some course corrections, and also for future sessions, like it will give us inputs how we should approach it, so that the community can benefit. So please feel free to express your views. Let us know what we can do better, or if you have done something very well, please point that out too. It will encourage us. Thanks a lot.
Thank you, everyone. It's a great weather today, right? So probably that's why we kind of lost a little bit, or maybe too much of coding, Harsha. We may probably have to stay towards theory. I don't know. It's a good data point also for us to analyze, right? Together.
See, if you don't get to the practical aspects of it, so there are many who mention, even says Samuels, Mickey, they participate in study circle. So we've been talking to. So there are many who express that. See, at the end of the day, theory is theory. It will you can get the theoretical. Only when you see the practical use of it, you will be able to appreciate it, and you can claim that you know that you've seen it. Not complete real world example, but close to that, so that you know how this theory gets translated into the practical portion, right? That's the reason we are spending some time on the coding. It is going to be heavy. See, TensorFlow neural networks itself is a very heavy topic. It's not something which is uh, people struggle. See, I know many friends. If you look at Andrew Ng's course, machine learning course in Coursera, week 4 and 5 are neural networks, and they struggle a lot. By the time they finish week 4 and 5, it's not week 4 and 5, it is week 10. And if you to see in terms of calendar, so it's the same thing because he deals with it that way. And we cannot completely avoid that because the topic
No,
itself
no,
is
no, no.
complex. I
Don't
haven't
get
gone
me wrong.
into some
Yeah,
details like,
yeah.
see,
Don't get me
optimizer can
wrong.
be a separate topic together. So
Yeah,
there are a lot of activation function can be. I can speak for an hour about activation function, right? So there are, but I have deliberately not gone there because it might sound a bit theoretical. Statistics might come in those things. So I've kept it at a level where I can also convey the ideas at the same time, convey theory plus practical aspects. That's how I've planned my course.
I mean, it's a wonderful course content, Harsha. Don't get me wrong, right? So that was yeah. Don't perceive me wrong. My point was that we need to kind of little bit understand from last week to this week. There has been reduction in the attendance, right? So why is something that we need to understand as a team so that we can perform a little bit better. That was my point, right?
Okay.
My point was not to not to take the coding.
Okay.
I just want to clarify, not to be perceived incorrectly.
Yeah. It might
But
be because the topic is a bit
wonderful.
heavy.
I mean, for me, I enjoyed your session, right? It's for me, even though I'm a business person and I'm a technologist, I enjoyed your session. I know now at a very high level all the concepts, but I don't intend to write any single line of code. I've outgrown that, but I definitely enjoyed your session, top notch. There's no two doubts about it, Harsha. That's pretty clear. And one more session to go. I'm more excited. And also sad, this is going to be only one more session, right? And I'm looking forward to another topic which you're going to take on September. So yeah, it's a wonderful session, top notch delivery. And I'm pretty sure that everyone in this call will also second that, right? About what you delivered. Great work, great work. Any other questions from anyone? If not, we can close the call,
Yeah,
guys.
I have one. How do I join the meeting for the business board that should be doing?
Huh?
Entrepreneurs. You got something like for
It's all in the Eventbrite, Samuel, right? All our programs is in Eventbrite. You go to the Eventbrite, you register, you get it. Yeah.
what is it called though? I don't know what it's called.
What do you mean?
That financing or whatever you're doing. What is it called?
Desktop
If I
projects.
look,
It's called
Project.
desktop projects.
So if you go to that,
what?
you can actually this one. There's projects, open source, right? Career path and learning path. So this
Okay.
it's called as Testoper projects. Yeah. And another
Okay.
thing, Harsha, we need to also kind of think about like how long are you going to support the study group, right? And then we need to probably also change the end date for the study group based on your availability to support them.
We already discussed that, right? It's going to be 1 week after the last session, right?
Okay. Then we got to probably in our programs team meeting, got to redo this accordingly. Okay, perfect. So you got your answer, Samuel?
Yes.
Perfect.
Yes,
Perfect.
sure.
Thank you, everyone. Do not forget to shut down your computer before finishing the survey. Thank you very, very much for that. From my end, I'm
Do not
close.
forget to fill the survey before you shut down your computer.
Yeah, do not forget to fill the survey before you shut down the computer. And that's my last word, Harsha. I'll give it to you, the privilege to close this session, Harsha.
Okay. So last comment, I know the session might have been heavy. The recording will be there in YouTube. go through that again. If you have any questions, um, I've covered like model building from data import till validating the model, saving the model um, for taking it to production. So go through that. This should give you a good idea of like how the processes you can. It's not a bad idea to look at some Kaggle data sets and use this knowledge to do some predictions there and see how your model is behaving. So it will give you, the more you try, it will give you better idea about how you can proceed. And when you run into issues, feel free to search the net. There are tons of material which is available. You can, I mean, of course, you can try to reach out to us, but beyond that, if you want to also try on your own, search the net. Like for example, like what optimizer function should I use for this? What activation function can I use for this problem? So these are things there's material available. Stack Overflow has answers. There are several sources of information which you can look at and try to experiment, and that's how you will learn things. Okay, with that, we are there to support you. Reach out to us if you have questions, and I'll close this session. Thanks a lot. Thanks for your participation.
Thank you.
Thank
Good
you very
day.
much, guys. Take care. Bye bye. It's a
Thank
good
you.
weather outside. Stay safe, but go out. Take care. Bye bye.
Thank you. Bye.